calculate the free energy of the Micelle state. So today we're going to just do a very quick qualitative assessment of what are going to be the free energy contributions in our Micelle state. So we saw our disordered state here. Actually, we drew it in the previous page. So in our disordered state when we're mixing, but in the ordered state, we're going to have our micelle, like we see actually, go back, like we see right here. So what are going to be the energy contributions here? Well, we know that some of those chains are going to be stretched. So you're going to have some stretching like you can see here. So there's going to be some stretching component. There's also going to be some favorable mixing in the corona. So there's going to be some mixing there. And we basically are forming an IMDS, intermaterial dividing surface. So there's going to be some unfavorable interactions IMD that we have to deal with there. So we're creating essentially, again, some interfacial energy, some interfacial area, some surfaces. So we are going to have to take into account and look at those three different and distinct free energy terms. So specifically, energy penalty due to stretching, so either stretching or compression of our chains in the corona and the core. So we're going to have that entropic string restoring force. So entropy penalty due to stretching, so S stretch. We are also going to have a favorable increase in entropy due to mixing. So we have delta S mix due to, again, this is specifically for homopolymer and then the diblocks in the corona. So homopolymer, diblocks in the corona. And then again, the energy penalty due to creating that interface, the IMDS. So those unfavorable AB interactions here. So these are going to be our three different contributions to the free energy of our micelle state. So we're going to break down these each piece by piece and again get the free energy in terms of energy per polymer. So look more forward to that, tackling stretching in the next video. I'll see you all next time. Thanks.